Hello and welcome back. In this section, we'll introduce ourselves to the basics of Python programming. And if you are very new to programming, this one will serve as a crash course. However, if you're already familiar to programming, this one will also serve as, like a review. All the materials that we'll be using in this tutorial are available on our website. Here I have my Chrome open. Okay, you can just search for data idea, or you can enter science.dataidea.org, and then it will load this website. Again, it's science.dataidea.org. Okay. This website contains all the learning materials that we'll be using for learning Python. And on the left here, we can see the section for Python. There is other stuff like data analysis with Python and deep learning with PyTorch. If you check out here, there is the outline of the Python course. By the way, all these resources are free of charge. This is the entire outline. What I would just like us to do is I would like us to go to the basics just right here. Okay. Now, in this course, we will learn the basics and advanced concepts of the Python programming language. Uh, for the beginning, in the first part of this lesson, we'll look at the overview, introduction, and also I'll show you where we shall be writing our code. And then we'll look at what statements are, syntax, and comments. First of all, I would like to tell you Python is really easy. And the only things that you need to have to get started with this Python course is you should just be knowing how to use your computer, like creating files and stuff like that, opening your browser, for example. And then if you want to set up Python on your computer, you may just know some small knowledge of how to install a software, and we shall need a compiler. In this tutorial, we will be using Google Colab, and more on that later. Now, I just said Python is really easy because it's human readable. For example, we have an example here. Without me teaching you anything to do with Python, you can quickly see that, here we are assigning 4 to X, 3 to Y, and we are getting the summation, and then we see the output is 7. See, Python is really simple. Now, before we continue, I would like us to first, what is Python? Python is a programming language, and it is actually the most popular language right now alongside JavaScript. It was developed by a guy called Guido van Rossum in 1989. He's still alive. I think right now he's working with Microsoft, last time I remember. And it is used for web development, machine learning, data science, which we are using it for in this course, and also for automating stuff. The latest version of Python is Python 3. Okay, and this tutorial is gonna be based on the standards of Python 3. Now, if you want to install Python on your computer, you can follow this link. Okay, this link, python.org, it takes you to the official Python website where you can download. However, you don't have to install Python to follow this guide. We'll be using Google Colab, and more on that later. If you install Python, you may want to check out this section where you'll know how to create files, open the console. But for now, let's skip this part because we'll be using Google Colab. Okay, now in the first part, let's just see how to display output in Python. Now, again, as I said, all these resources are on the website, and in fact, I have a video here of the older iteration of this Python course. where I explain a lot of stuff. There's also another video here. If you want to set up Python on your local computer, that's an option. You don't have to do it for to follow along this course, but in case you want to, you can. Now to practice, we shall be using Google Colab. So let's just create a new tab and search Google Colab. Here, the first result is Google Colab. So let's just open that. And when you open the Google Colab website, you can see there is Open Colab and new notebook. We just want to create a new notebook. Okay, so let's just create a new notebook here. When you create a new notebook, this notebook is actually stored in your Google Drive so that you can access it later. And then also that means that all the resources that we'll be using in this video, this code that I will be writing, will be available. So a link will be in the description to the Google Drive, to the Drive folder that contains these resources, this file in particular. Now we'll be following this course, so I'll just put it to the side here, so that I'll have my Google Colab side by side with this uh, with this um, with this course page. Okay, and let me just resize. Okay, so like that. Okay, now before we begin to write some code, maybe let me talk about Google Drive, rather Google Colab. Google Colab is a place where you can write Python code. It comes, set with like everything. There is like a virtual computer behind that has a Python interpreter already set up for you. So the only thing you have to do is just open and begin writing code. We'll be writing code in this little black box. If you're using a light theme, it's probably white. And here we can just be writing code here, and then to run our code, and you'll see what running means. We just press this play button. To create a new cell like this, you can just come to the bottom, or you can just press this plus code thing. It creates a new cell. This thing is called a cell, a new code cell. Yeah, you can link your Google Drive and other things, but for now, let's just focus on practicing Python. Okay, so let's just get started. Here we have an example how to print out stuff in Python. Okay, so let me just increase the size so that we can see well. Okay, I think this is enough. Let me also increase this in 175, 150, 150. Okay, I think this will do. Now to print out things, we can see here we just use the print statement, the print function. So let's just begin from here. So I can just print, and then I write print, and then I open brackets, and inside brackets here I can type whatever I want to print out. Now I just want to print out text, and to print out text I put it in quotes like this. So in this example there is hello world, but I'll just use my name, just we get the intuition. And then to run I can press this play button, and now it's taking some time to display output because Google Colab is setting up for me a virtual machine that will contain a Python interpreter for my code, and this is only done once. Okay, when you load the site, so it will be quicker the other times, and it's done, and then we can see our output right here. Okay, Juma Shakara. If we wanted to print out like hello world, okay, it turns out that you can copy stuff from my website real quick because there is this button. By the way, I designed this website, so all the resources they are designed by me. We can copy this and we can paste it, like here. To paste, you can press here and you do Control V, and then you run. Now again, you run by pressing this play button, but you can also use like shift enter to run that cell. Okay, so I like to use shortcuts, so I'll be using shift enter, and then you can see hello world printed just like how it is on the website. If you want to print out a number, you can do the same. Okay, like here I'm printing out 27, so let me just print here 27, and it's 27, just like that. It's really 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 simple. Now if you wanted to print out two or more objects, you can put them in the print function, and just separate them with brackets. Okay, for example, here there is an example here. They're printing out hello, and then they put a comma and then Juma. If I wanted to print out Juma Shafara and a number like 27, I can do something like that. So I'll say print, and then I say Juma, and then I can put a comma, and then I print out a number 27. Now, as you can see, when we are printing out texts, we use these quotes. If we are printing out a number, we can just write the number without the quotes, and it will be printed. So let's just run this. And Juma and 27 are printed. Now, one thing you'll probably realize, if you print out like this, both items will be printed on the same line like this. So, just so you know, we can print out the result of an operation. For example, here we are assigning um, x to 3 to x, and then 7 to y, and then we get the summation, and then we print out the summation, and if I just copy this code and I put it in this cell and I run, we can see that the sum is 10. It's really really simple. We can put all this on one line, like in this example. I will not do that, but you can try it out in your free time. Okay, now in this part we shall look at Python statements. Every line of code every line of code in Python is called a statement, as long as it is performing a particular task. Okay, for example, here this section assigns 5 to x. This performs a particular task of assigning 5 to x, so it's called a Python statement. This one is a statement. This one is a statement that gets the summation of x and y, and then this is also another statement that prints out the summation. Okay, it's really really simple like that. You just have to know that every line is every piece of code that is performing a particular task is a statement in Python. Now here we have the statement separated okay, into 4 statements. However, you can have all these statements on one line like this by separating them with colons. Okay, so for example, we have this example up here. We can put it in one line by saying, for example, x is equals to 3, and then we put a colon, okay, and then we say y is equals to 7, and then we put a colon, and then we print out like that, print out x plus y. Okay, and it just works nice. I can actually just, instead of printing out x plus y, I can get the summation also, and then just do summation is equals to x plus y, and then I put a colon again, and then I print out that the sum is that. And if I run this cell, we can see that it still just like does the same thing. Okay, now in this other section I want to talk about the Python syntax. Now when coding in Python, we follow what is called a syntax. Now, a syntax is a set of rules followed when writing programs. So whether you are using Python or any other programming language, and even when you're just doing your day-to-day stuff, probably there is a way people agree that things should be done. Okay, it's not meant to technically complicate matters. It's just made to help us achieve a target that we want, okay, with maybe some degree of smoothness or clarity or something like that. Now, in Python, for now, what I want to say is that indentation is an important thing, unlike other languages, and an indentation is used to represent a group of statements. So, what is an indentation? It's that little space before before your code, before your statement. That little space at the beginning here is called an indentation. In this example that I included in the website, I have this number 4 assigned to number 1, 3 assigned to number 2, and then I have this if statement, and I'm going to talk about if statements in future. Here I'm just using it to illustrate the concept. Okay. Here we can see one thing. All these ones, the spaces before the statement, there is almost no space. Actually, there is no space before this statement. There's also no space before this statement. And there is also no space before this statement. However, these other two statements here, they have some space before them here. Okay, there is this little space, and then there is also this little space. This is an indentation to mean that this statement and this statement are a group of code falling under this if statement, like this. So when Python is interpreting this code, it will interpret this thing as one group, okay, and it will execute them as a group. Printing this one will depend on the result that comes from here. So let's just try it out and then see. I'll just copy this and then I'll paste it here. Okay, if I just run this, we print out hello world because number 1, which is 4, is actually greater than number 2. Now, one thing, if I remove the index, if I maybe push the indentation longer for this other part here, we get actually a warning. It's called let's just unexpected indentation here, like this, because this print statement is not expected to be at this level of indentation. Now, when you're just beginning, you may find some little problem with this, but I promise, as you practice, indenting stuff is gonna be natural, like like waking up and beginning to talk. Okay, you don't even think about it. So I'll just leave it at that. More on that later. I just wanted you to know that there is some rule about how we can handle certain things like this. Okay, now in the final section of this part of the tutorial, just want to talk about Python comments. Now, comments in Python are just some pieces of text that we include in our code to explain what is happening to other people that may be viewing our code, even to ourselves. It turns out that sometimes code can become maybe large or complicated, that you may also need to be reminded where what is happening, and we use comments to do that. Comments are not interpreted, so when you write them, for them they are not run. Now, for example, I have this other example that I wrote before. I can add here some comments. So to write a comment, I can just use a hashtag like this at the beginning, and then I put in my comment whatever I want to explain that is happening here. For example, assigning uh, assigning values. Okay, maybe that is what's happening. And then here I can add a comment saying obtaining the summation. Okay, that's a comment. And then here I can say printing out the output. Printing, oh, hashtag, let me just say displaying the summation. Okay, when I run that cell, okay, we'll see that the result is gotten, but these other things, they are not printed or interpreted in any way. These are just comments. Now, to wrap up this section, okay, I just want you to try completing this little exercise here. And in this exercise, you will just try to print out this. So spend a little moment to complete it. You can pause the video, then I will show you how the solution. Okay, now I will display the solution to this exercise just right here. If you haven't tried out and you wish to try, you can pause and try out before I display. So the solution here is print. Uh, I can print all these, all of these ones separately. I can set data ID, and then I can print again another thing, and I can print this other part, Sapolo Kabwa Road. Oh, by the way, this is our location. And yeah, I can do another thing. I will print open quotes, and then I print Kampala. Then I also print Uganda, and then I can also print all these dashes. And finally, we shall print the website, www, it's also in quotes, www.dataidea.org, like that. So if I run this, you can see the result as it is displayed here on the exercise question. So that brings us to the end of the first part of this Python course. You can put your comments in the section. If not, then we'll also resume to the next part shortly. In the next part, we'll be looking at Python variables. Okay, so you can take a little break, pause the video, and just take a break, and then we'll resume. Right, welcome back. In this section, we'll be looking at Python variables. This is the solution from the previous part. Again, all these materials are available on our website. I designed this website. It's called Data Idea Science, the dataidea.org. You'll find all the learning materials regarding data science and Python for this course particularly. Um, we'll be looking at Python variables, and without wasting time, let's just jump in and get started. We'll be looking at uh, data types, numbers, strings, type conversions, and booleans. On the website, there is also an optional video. I recorded that video earlier on, so if you want, you can check it out. Now, before we get started, here's the thing. Instead of adding everything right here, let's just create a new notebook where we'll be running our Python code relating to Python variables. So to create a new one here in Google Colab, again, we are using Google Colab. You can just click on File, and then you can open new notebook in Drive, okay, and that will open for us a new notebook, and we can rename this notebook maybe to be Python variables. Once it loads, you'll see some section here saying untitled, so you just remove that untitled section, and then you just give it a name that suits whatever you are doing. Okay. Yeah, we'll just begin. Now, variables are stores of value. When you are doing your data science stuff, you may receive different sorts of data, and you may store this data. You may want to store this data somewhere so that you can, you reuse it for some purpose. Okay, you may have some numbers like age, number of maybe rice bags, or countries, or something you may want to store. We use variables to do that. The way we do it is we pick a name to represent what we want to store. Maybe like uh, age, okay? And then we use this equal sign, and then we set the value for this object. For example, maybe 30, maybe 45. Okay, so in this case, 45, the number would be stored in this uh, uh, variable age. Okay, and we can prove this by, if I print out age right now, we'll see that the thing that is gonna be printed is gonna be 45. Now it's taking a second because it's still setting up for us our virtual machine, which has the Python interpreter. Once it's done, we'll see the output. Yes, right here, 45 as the value. Okay, if you wanted to store a name also, you can just do that. Okay, let me just move it up, and this one can be like Juma Shafara. Okay, and we can print out the name also. Here we'll see the name printed out, and then we also see the age also printed out. Okay, so this is how we store items in Python. Okay, there's more examples on the website. Now there are some rules to consider when picking names for variables. In a variable name where you have more than two words, it's advised that you don't put spaces between the words. This can cause some problem. For example, if I say my name, okay, is Juma, okay, we see that if we try to run this, we get into something called a syntax error. Okay, this little space isn't allowed between variables. Instead, you can use an underscore like that. Okay, now when I try to print out my name, this works just fine, as you can see. The other thing is letters cannot start the variable name. So for example, if you wanted to do first name, you cannot use one name like this. This is problematic. You run into errors. Okay, so you see also syntax error. Instead, you can use first name like this. Okay, and then you can maybe print first name. Okay, this will work just fine. Now the other thing is special characters aren't allowed in your variable names. Okay, so for example, if you want to have name, you cannot have like this @ symbol in your name. Okay, let's just see what happens if we have that. If I run again, we have some problem. Okay, so don't have this. Instead, you just use the normal characters only. This will just be fine. And if we print out now that one, we see that we get the value. It works just perfect. Here are more examples of good variable names. Okay, and now here's the thing. If you want to keep updated with data science stuff and the Python courses, you can enter your email on the website sciencedataidea.org. There is this little section in the course materials. You can enter your email there so that you can receive updates directly in your email, or you can also follow us on X and YouTube, to keep up to date. There are the other thing that I want us to talk about is Python data types, and there are not so many data types in Python. Some of them we'll be looking at include the numbers. Now, a number in Python is a number as you know it, and there are two types of numbers, two major types of numbers. There is an integer number, which is a number without decimal places, like our age here, it's a number without decimal places. And then we have a floating point number. A floating point number is a number with decimal places. For example, this weight here, this weight value, is a number with decimal places. If you want to check the data type of an object in Python, you can use the type method. This is how it works. You just say type and then you pass in the object, in this case the weight. So I can store this to a variable, maybe like weight type. Can't type today. Weight type, and then I say it's equals to that, and then I can print the weight type like that. Okay, and once I'm done, we can see the data type here is float. Okay, it's really simple. More on numbers, I have a separate tutorial only to handle numbers. So on the website, there is a link to that tutorial. Just check it out. Okay, it's dedicated to numbers only. Okay, you can check it out. I have a tutorial and a video, all of them. Here we have strings. Now, string is also another data type in Python, and string is simply text. For example, this name that we have, it's a text. Okay, all these names are texts. A statement now like this, I love coding. You want to store it as a text now, as a string. The way we store strings or texts is we set them in quotes like this. For example, Kampala, it's a city, and then we can store them in a variable, like city name, okay, like that. And if I just print out this for completeness, we can see Kampala like that. Okay, more on strings. I have a dedicated video and tutorial on strings. Also, they are all on the website. If I just click, for example, here, we can see there is this tutorial dedicated to strings. Okay, quite some few things there. The other thing I want to talk about is booleans. Booleans are data type that can only have two options, like true or false. Now, booleans are usually as a result of evaluated expressions. For example, if you checked whether some weight here is greater than, just copy this. If you are checking whether, so let's print weight is greater than maybe 20. If you are checking whether the weight is greater than 29, this one will return a boolean like this. And more on this later when we are practicing. However, what I want us to note is that booleans are usually written with uppercase. The first letter is usually uppercase. If you're coming from a different background, maybe from JavaScript or some language like C, C++, those people are probably having either a small first letter, and also some of them use numbers like 1 and 0 to represent true or false. Here we use a whole text like this, and the first letter, it should be capital like that. There is more examples on booleans on the website. Here you can see 5 is 5 equal to 5. It evaluates to true because it is true. Is 10 greater than 5? It returns a boolean, also true because 10 is greater than 5. Is 20 less than 10? It returns false because 20 is not less than 10. That's not true. Booleans are also used in if statements. So if statements allow us to run some particular logic if a given condition evaluates to true. Okay, and more on that later. For now, I will just leave that. Now, the other thing I wanted to talk about is lists. Now, a list is technically a data structure, and for now, I just want to consider it as a composite variable, a composite data type rather, data type that is resulting from combining other data types. A list allows us to store very many objects in one item, in one container. So to bring up the definition, a list is an ordered collection of data. It can contain strings, numbers, and can even contain other lists. And the way we write lists is we use square brackets. So for example, we can just open square brackets like this, and we can add in here names of people or names of cities. In this example here, I am having names of people, but here I can use names of cities like Kampala and maybe Kenya and maybe uh, I don't know what is that thing. It's called Zanzibar. I don't know. Madagascar. Okay, Zanzibar. Let's just so we can store this list in a variable called maybe cities. Okay, and if we print out cities, we shall see all cities here like this. Okay, these are stored in one container as it is. Now, more on lists. I have a specific tutorial that focuses on lists. However, we shall use lists as we go on later, so you will hone your intuition very well about lists, and have also a special section for containers. Now, one thing is you may want to convert an item from one data type to another. For example, you may want to convert an integer or a floating point number like this one to an integer, or you may want to convert an integer to a floating point number. You may want to convert a string to an integer, and so on and so forth. We have what we call methods that convert. For example, the string method converts an integer to a string. We have the int method that converts an integer, okay, to that converts whether a floating point number to an integer, or maybe a string number to an integer. Then we have a float, okay, that converts an integer to a floating point number. To give an example, I'll use this pi. Okay, so let me just use pi, and I will have 3.14159. Okay, that's pi. And if I want to round off, I will say if I want to convert this one to like an integer, okay, so I'll call it integer pi. I will just use the int method, say int, and then I say pi. If I print out this value, int pi, we'll see, it returns the integer. And when you round off 3.14159 to the next integer, it's 3. Okay. Okay, it's like that. It's very simple. Now here I have some little exercise, and this exercise I wanted to skip it, but if you want, you can note it down and you can do it in your free time. It's saying write a program to assign the number 34.5678 to a variable named number, and then display the number rounded to the nearest integer value. Now we'll come back to this question when we are looking at numbers and number methods. If you want, you can do it, but for now you can press skip. Okay, with that, we come to the end of the second part of the tutorial. Let's prepare ourselves for the other part. In the next part, we'll be looking at operators. Okay. All right, welcome back. In this section, we'll be handling Python operators. As before, we'll just create a new notebook that we'll use for Python operators. So we just click on File and then we say New Notebook in Drive. Okay, this will create for us a new notebook, And in this notebook, well, practice. Now, here's the thing. Python operators are symbols that perform operations on operands. Now, an operand can be a variable or a string or a number or even a boolean. So we'll be looking at these following operators. We'll be looking at arithmetic operators, assignment operators, comparison operators. We shall have several examples. Then we have identity operators, logical and membership operators. Again, all these materials are on the website science.dataidea.org, and if you are looking forward to getting updates ASAP, you can enter your email in this section on the website so that you'll just get details inboxed in your email. Now, let's just get into arithmetic operators. Now, arithmetic operators are symbols that perform mathematical operations. For example, we use the plus if we want to add numbers. We use this minus symbol if we want to subtract numbers. We use this forward slash if we want to divide numbers. We use this asterisk. It's called asterisk, not a star, if we want to do multiplication. And then we use this double asterisk to do exponentiation. We use this percentage sign, also called modulus, if we want to get a reminder when we divide any two numbers. And then we use this floor division if we want to get a whole number when we divide any two numbers. Okay, so let's begin with the addition operator. The addition operator returns the sum of its numeric operands. As you can see here in this example, we have x assigned to 10, and then we have y assigned to 5, and then we can get the summation as x plus y. This was like our first example, as far as I remember. Then we can print the summation. Again, this will just take a second as the virtual machine is created for us, and we'll see that the summation is 15, just like this. Okay, now what happens when we use strings with this operator? It turns out that this plus or addition operator can do what is called string concatenation when you put two strings together. In this example here, I have the first name as Juma and I have the last name as Shafara, and I'm using the plus to get the combination of the two, and then I store that in full name, and then we print out the full name and we can see the full name is Juma Shafara. Okay, it's really, really simple. Then we have the subtraction operator. This is an example. Again, 10 and 5, we just do like this. So subtract, and we see the difference is 5. An example for multiplication is right here, and the example results into 50. Another example for division is here. When you divide 5 by 10, you get 2.0. And notice that when you use the division operator, the outcome is a fraction. It's a floating point number. It is always a floating point number. Even if you get 10 divided by 5, you get 2.0. Now here we have the exponentiation operator. Now here x to power 10, this is what it would mean. X to power 10, rather 10 to power 5, sorry. Exponentiation 10 to power 5, and this is like 10 5 times, and it results into this 100,000 value. Okay, if you want to get a reminder when you divide any two numbers, you can use this reminder operator, also called the modulus. So you just say x modulus y, and then you get the result. Here it is 0. It's a really simple example, that's why I'm going really fast through this. There is this other example where we get the floor division, and we said floor division rounds down the quotient of its numerical operands and returns the nearest whole number. So 10 divided by 5, rather 10 divided by 4 is like 2 point something. Okay, and it rounds down to just 2. Okay. Okay. The operator sequence. Now here's the thing. It turns out that you can use very many operators in just one expression. For example, in this expression, we get 10 times 3 divided by 2 plus 1. Now, operators in Python have what is called uh, precedence, where an operator is considered to be of a higher precedence than another. So if for example, the multiplication sign and the division operators have higher precedence than the plus and minus, they will most likely be considered first if it is an open operation like this. So let me just copy this one and then we just see the result. So if I run this, of course, we are seeing we get 16. How it comes is we get this one 10 10 I think when we use the BODMAS, it's a division that comes first usually. So we shall have like 3 divided by 2 times 10 plus 1, I think. So let's just see that 3 divided by 2 is what? 1.5. 1.5 times 10, that's 15. 15 plus 1, and that's 16. So if you remember BODMAS, uh, it applies in this sequence. Now here's one thing. If you have a particular operation that you want to go first before another, you can apply maybe brackets. For example, we can put 10 times 3 into brackets, and for this one 10 times 3 will be performed first before it is divided by 2. And for example, this will be 30, and divided by 2 is 15. Sort of returns the same thing though, but okay. Yeah. However, if you wanted to maybe say divide by this, okay, this would return, I think, 10. Bit 30 divided by 3, okay, this would return 10. Okay. The other type of operators I want us to look at are assignment operators. Now, assignment operators turns out there are quite many, many more than you thought, probably. uh, yeah, the first assignment operator is the equal sign, and what it does is that it is used to store a given value on the right to a variable on the left. For example, x is equals to y, will store y into x. Okay. Uh, Here, if we have x is equals to, maybe we have a certain number is equals to 7, it will store 7 into this variable number. And we proved this one last time. If we print out number, we shall confirm that number has the same value as 7. There is this one addition assignment. Now, addition assignment looks like this: plus equals, and what it does is that it gets the previous number and adds on the new number and stores the outcome in the old variable. Let me just demonstrate with this current state. If we have number as 7, we can do number plus uh, plus equals to 3. And what this one will do is that it will get number, which is currently 7, plus 3, which will become 10, and it will store the result into the variable number. Now, if I print out number will have become now 10. Okay, it's like that. Let me repeat. What happens here is that when you use this as addition assignment, it will get the previous value of number, and then it will add to that value 3, and then it will store the total outcome in the old variable number. Okay, in this case the result will be 10. Same situation will happen to subtraction assignment. Okay, if I just select all this and I just use it in a new cell and I do minus, we'll see that yeah, we have 7, the old value, minus 3, which is 4, and the result 4 will be stored in the variable number, and then we are able to print out 4. Same for multiplication and for division and for exponentiation, then for remainder and floor division. Here are all the examples on the website. Again, all these materials are on the website science.dataidea.org. Here we have an example for assigning 10 into a number. Here we have addition assignment. Here we have minus subtraction assignment. And then this will take us to the next type of operators that we should discuss, which is comparison operators. Now, comparison operators are used to compare operands, and they return a boolean based on whether the comparison was true or false. We have several of them. We have the first one here is equality, and equality is used to check if the given values are true, rather are equal, sorry. It will check if the given values are equal. The inequality will check if the given values are not equal. Then greater than will check if the given values are they give one value on the left is greater than the value on the right, and we use this symbol here. For equality we use double equal. For the other one we use this exclamation mark and the equal sign for inequality. And then we have less than, and then we have greater than or equal. You can imagine what it does. Then we have less than or equal. Also, you can imagine what it does. It will check if the value on the left is less than or equal to the value on the right. And here we have some examples. We have voila and viola. These ones are not equal, so it will return false, as we can see, because voila is not the same as viola. And then we have 5 equal to 5. This is true because 5 is equal to 5, so it will return true. Here we have the inequality, voila and viola. This one will return true because voila is not equal to viola. The inequality operator checks if the value on the left here is not equal to the value on the right. If it is not equal, it returns true. If they are equal, then it returns false because they are equal. Okay. Here we can see 10 not equal to 10 returns false because 10 is equal to 10. We have the greater than operator. Here we check for 8 greater than 4, which is true. Okay, and then we check for 5 greater than 10, which is false, as you can see in the output. Then we have for less than, then we have for greater than or equal, then we have for less than or equal. And here I have the body mass example. Now you can go to the website and revise these. All things that I'm discussing here are on the website, science.dataidea.org. Here we have a body mass example where we have the weight as 56 and then we have the height as 1.5. We can use several operators. Here we have the formula for getting body mass index is weight over the square height. So we can get our weight, okay, and we divide by the square of the height. We can get the square of the height by saying the value of height double asterisk 2. This one will get height power 2, okay, and then the result will be stored in BMI, and then we can print out BMI. Okay, the BMI for this one is 24.888889. Okay, if again I'm going too fast, it's because I consider this a bit light, and however you can go to the website and revise. All these materials will stick there, they will be available. The next type of operators I want us to look at are identity operators. Identity operators are used to compare two values to determine if one value points to the same object as another value in memory. This one sometimes can be confusing new people, but you'll get used to the idea. If we have, for example, in this example, x is equals to 5, and then we have y is equals to 4, we can check if x is y, this one will be false because x does not point to the same value in memory as y. Okay, however, if I modified this one, say like this, if I create a new variable, say z, and I say z is equals to x, now z and x will be pointing to the same object 5 in memory, and therefore if I checked now whether x is z, we shall see that this one becomes true because x is pointing to the same value 5, z 5 in the memory. Okay, then is not is like the opposite of is. It checks if two values are not pointing to the same object in memory. Okay, the other type of operators are logical operators, and these are also commonly used with booleans. So in Python there are like 3 of them. We have the AND operator, and this one will check if two conditions passed are all evaluating to true, and then it will return true. Otherwise, if one of the expressions is resulting into false, it will return false. We shall see in the example. And then we have OR, logical OR, and logical OR will check if one of the conditions passed is true, then it will return true. Otherwise, if both conditions are false, then it will return false. Then the NOT operator is, as we shall say in the example. Let me just jump to the example. In logical AND, we have x here as an example. X is equals to 4, and then we are checking, is x greater than 3 and y less than rather 8 less than x. So here's the thing, x greater than 3 is actually true. Okay, 4 is greater than 3. However, 8 is not less than 4, so it means that the expression on the right is false. So this entire result will be false. So AND will be used to check if two conditions are both returning true, then it return true. If one of the conditions is returning false, then it will return false. Basically, it's like saying, is 4 greater than 3 and 8 also greater than rather less than 4? That is not true. So it becomes false. Then logical OR, an example for logical OR, I have the expression here. 10 greater than y by the way has been set to 7, and then or 4 greater than y. Now the way we want to interpret this is 10 greater than y or is 4 greater than y. This is true because one of them is greater than y. 10 is greater than y. Okay, so it becomes true. This condition evaluates to true. So we just want one of the situations to be true. More on the applications of this as we progress in the course. More other examples will be available to hone your intuition on this concept. Then we'll have logical NOT. Now, logical NOT is just used to return the opposite of the result. So it will return true if the operand is false, then it will return false if the operand is true. In this example, we have z set to 8, and then we are saying in our expression 3, we are saying not, and then we open brackets, 10 equal to z. So is 10 not equal to z? Is 10 not equal to z? So it returns true. All right. So it's because, as we said, it returns the opposite of the expression, the result of the expression. So 10 equal to 8 is false. And then when we add the negation on it, not, it becomes true. Okay, as Avila said here, not false is true. Okay, now again, sometimes some of these concepts can be tricky in the beginning, but as you practice more, your intuition is honed and things just become a bit easy. And we'll be having enough examples for us to hone our intuition. The other last type, I think, the last type that we'll be looking at here is the membership operator. Membership operators, I used to check if a sequence is present in an object, like maybe a string or a list. In the previous section, we learned of an item of an item or object called a list, and we created a list of cities where we had like Kampala, and we had like Kenya, and then we had, was it Zanzibar? Okay, and then we stored this to a variable called cities. Okay, we can check if a given city is in this list, okay, by using the membership operators in or not in. Okay, so in checks if a given city is in this list. For example, we can say print Kampala in cities, and then we can see that is true because Kampala is available in cities. However, if we use print Kampala not in cities, that one will return false here because Kampala is actually in cities. So when you say not in, it means, it's not true. That's not true. It's not, when you say Kampala is not in the cities, that's not true because it is in, so it returns false. They're not in operator. Again, there is more examples on the website here. Okay, and for the end of this section, we shall have a simple exercise. It's saying a car increases in velocity from U to V within t seconds. Write a program to calculate the acceleration. Uh, okay, you can try this one. You can pause and try this one. However, if you are still on, let me just write a solution that I expect you to have. So the acceleration is equal to uh, the acceleration is equal to v minus u over t. Okay, is the change in speed over the time. Yeah, if I remember. So let's create these variables and store some values in them. So let's assume, so I'll say let v maybe the final velocity be 10, 19, and then let u be 15 and let t be 3. Then the acceleration will be that. Okay, if I print out now the value for acceleration given those values, we shall see that the acceleration was 1.3333 meters per second, I think. Okay, that's it for now. See you in the next chapter. In the next part, we shall be looking at Python containers. This part of the course, we are gonna be looking at Python containers. Okay, now before we get started, let me just create a new notebook as usual, and in this notebook is where we'll be practicing containers from. We'll look at, first of all, containers. Let's define them. Containers are objects that contain other objects. Okay, so there are several situations when we want to put several items into one object. Okay, so that we handle them as one collection. And we can do that with containers. Earlier on, we saw one particular example, which was a list of cities. I think it was a list of cities where we had like Kampala, and then we had Kenya, and we had Zanzibar. Okay, this one was a list of cities, and it turns out that there is also other containers other than just the list. We have tuples, we have sets, we have dictionaries, and I think for this meeting we'll be looking at lists, and we shall look at sets and dictionaries. Others you can go, if there is others that you want to look at, maybe you can find them on the website, this science.dataidea.org. Again, how you can find it, you can just search, for example, data idea. Okay, and you see the first result here, most likely the first result. Okay, and you can, this is the home page. You can select data science, get started, and it will take you to the science data idea site, science.idea.org. Okay, let's continue. So the first thing that I want us to accept here is that in Python, everything is an object. Even a statement like this or a number, it's an object. And we'll look at objects also later in this course. But sometimes what I want to say is that you may want to keep objects in other objects. Okay, again, that will take us to what I said. Containers are objects that contain other objects. An example here, we have fruits. In the last example, we had cities. We can confirm the type here of this container. For example, this one is cities. We can confirm its type by using the type method. Okay, then we just print out. We can see that this one returns type list or class list. Okay, it's a list. A list can contain different objects of different data types. Here in this example on the website, we have a string, which is my dog, and then we have some number 21, and then we have a boolean true in it. It doesn't mean that you can always do that, but it's a thing that is possible. Now here's the thing. Many times when we have created our list, as we said, the list will put together these objects as one collection. You may want also to be able to access some particular items in that list only. If you want to access a single item in the list, we use what is called indexing. So indexing is a simple technique where we just use square brackets. So in this example, we can say if we want to access Kampala, we can say cities, and then we put some square brackets, and then we put 0 inside here, and then this one returns Kampala. Okay, Kampala right here. So let's just print out properly. Returns Kampala. But you see, I've used 0, and you may be wondering why. It's because 0 is the first number in Python. Counting begins from 0. So in indexing, we put the position of the item that we want to access in between these square brackets here. So for example, if we want to access Kampala, it is in position 0. If we want to access Kenya, it's in position 1. If we want to access Zanzibar, it's in position 2. So 0, 1, 2. Let me show you. If I want to get Kenya, I'll put 1, and then we have Kenya. If I want to access Zanzibar, I'll put 2, and then we have that Zanzibar. Okay, it's really simple like that. I have another example where I'm using pets on the website. Okay, you can check that example out. We can also use negative indexing to get items from behind. If you want to pick the last item, for example, this side, you can use -1. So let me just try that. I'll print cities and I'll put square brackets, then -1. This one will automatically return Zanzibar. So this is applicable where you have a really long list maybe, and you just want to pick out the last item. Maybe you don't know the number of elements in that list and you just want to pick out the last item. You can use -1. So I have more examples on the website. You can check them out. And then if you want to access many items at once, particularly if you want to access a range of items, okay, you can use the what this small colon here, and I'm just gonna show you an example of how to do that. So let's just put it like right here in between here. Maybe let me first delete these other ones. Should I delete? Okay, let me just skip them. Okay, let's just come in. If we want to access all cities between 0 and okay, if we just want to access these two, Kenya and Kampala, we can do this. We shall access cities, then we open brackets, and then we can set from 0 and we put 2 like this. 0, then put colon, and then we put 2. So how it works is that the item on the left side of the colon is the position where I want to begin from, and then the item on the right side of the colon is the position where we want to stop. Now if I run this, we'll see that we get Kampala and Kenya. Now we only get Kampala and Kenya even if we put position 2, which is actually Zanzibar. It's because the last item, the position 2 here is not included. Okay, so this is how it works. If we wanted to get from Kenya to Zanzibar, we can also do from 1 to maybe 3 like that. Okay, so that returns Kenya to Zanzibar like that. If we want to pick out all values before Zanzibar, we can also just use this. We can just leave the beginning part empty, and then we put the position of Zanzibar here too. So this one return all values before Zanzibar. If we want to get all values after Kenya, we can say 1 and then we leave the other side empty like that. So this one return all values. It will return even Kenya inclusive. So yeah, if you want to return only those after, then you can begin from Zanzibar onwards. So like this. Okay, but there is only Zanzibar after Kenya. If there were others, let's just include another one so that you can confirm. So let's call this one Entebbe. So if I try to access all values after Kenya now, we have Zanzibar and Entebbe. Now, after creating a list of items, for example, here we've created this list of cities, you may as well want to add more elements to this list. Okay, I've just copied this list. You may want to add more elements. So how do you add more elements? To add more elements, you can use the append method. The way we do it is we can say, for example, cities dot append, okay, like this, and then inside these brackets we can add the city that we want to add to this list. So in this list so far we only have Kampala, Kenya and Zanzibar. We can also add there maybe Arua. Okay, and if I print now, the list will be containing all these cities. I can also add another city, maybe like Mbarara. Okay, and if I print now, we'll see that um, there is Kampala, Kenya, Zanzibar, and another one on this other side. It's Mbarara. Okay, like that. Okay, this is how you add one single item. Now, if you want, how about if I wanted to add very many items? I'm gonna leave it to you as an exercise. Just go and search if how to add very many items to a list. Okay. Now, there is more other ways to add items to a list. For example, there is insert. Okay, but I'm not gonna do an example, but there's an example on the website here. For example, insert will put a new item to a particular position in the list. This one inserts rabbit to position 0. This one inserts hamster to position 2 of um this pets list. Okay, what I want us to look at is how to delete an item, and there are several ways to delete items from a list. One way is to use the pop method. Okay, so let me just in a new cell, if we have a list of cities like that, we can use pop to remove some item. And the way it works is you just say cities, for example, dot pop. And if I print cities now, we shall see that Zanzibar is gone. So what just happened? It turns out that pop will remove the last element in a list. Okay, pop removes the last element in a list. Okay, now sometimes you may not be wanting to remove the last element in the list. So there are other ways to remove elements. For example, there is remove, which removes only the specified item from the list. So I'll just say remove, and then inside the brackets here, I'll insert Kenya. So when I display the lists, we can see that Kenya has been removed, and now we only have Zanzibar and Kampala. Okay. Other ways include delete, and delete will also delete an item at a given index. I'm not gonna run through that example, but just know it is there and you can find it on the website. Okay. Now, the other thing you may be interested in is finding the number of elements in a list. Okay, this is a really, really common thing, and we use the len method to find the number of elements in a list. For example, if I have these cities, okay, and I want to find the number of elements, I say len, and then I open brackets. Inside here, I pass in cities like this. Okay, this one will return us the number of elements in this list. Okay, so I can store this in a variables, maybe cities count, and then I can print out that one instead, just to be more organized. Okay, and this is 3. It's really simple. Now I want to give you some homework. I want you to go and search how to find if an item exists in a list. Now, I actually did this one in the previous section. So if you remember, you can do it. If you don't remember, well, just think, think and see how you can go about it. The tip is that you use the in operator. The in operator checks if an element exists in a container. Okay. Now, the other exercise that I had given you, if you want to add very many items to a list, you use the extend method, okay, and it is right here. I'm not gonna go through it, but yeah, you use this to add very many items to a list. So just go to the website and check out the other data structure that I want us to look at, or container, is sets. Okay, and again, by the way, I have videos for list sets all on YouTube. You know, you can just go watch. I have them on YouTube and also on the website. For example, in this video I talk about these sets and how they work. In any case, let's just have a look. A set is a collection of unordered and immutable objects. So sets are elements in a set are unordered, and also they cannot be changed technically. So we create a set using these curly brackets, okay, and objects are placed inside these curly brackets separated by commas. Here we have an example of pets. I can continue with my example of cities, okay. So instead of having these square brackets for a list, I'll just replace them with these are curly brackets for my set. So this one is a set, and we can confirm that it's a set by printing out the type. So maybe let me just run this. See, it says set. Okay. Now a set can also contain items of different data types. Here we have dog, 21, and true all mixed up in the set. Okay. And the way we access elements for a set is a bit different. It's because elements in a set don't have a particular position. So you cannot say I'm accessing an element in position 1. So we can use a for loop, for example, to access elements in our set. And in this, the for loop basically just looks like this. We say for, if we have some items in a set like this, cities, we can say for city in cities and maybe print out a given city. Okay. Now here's the thing, I'm going to talk about loops later in this course, but just know that this is how a for loop looks like, and this is how we can access elements in a set. This is one way to access elements in a set. Now, if you want to add elements to a set, you can use the add operator, the add method rather, to add a specific element. Also, you can use the update method to add very many elements. An example is here. If I want to add Mbarara to this set, I can say cities.add, and then if I print cities, we can see Mbarara has been added. Okay. You can also check out how to use update. I'm not gonna show you that one right here, but I have another video that discusses only sets. Okay, you can check it out. And accessing elements, we finished that. Now we shall look at the other thing, removing set elements. Now to remove a set element, we have the remove method, and the way it works is if we have just a set like this one, we can say cities.remove Kenya, for example, and if I print out here, we can see that we only have Zanzibar and Kampala left. Okay, remove does. Another method is discard. Okay, discard will also remove a given a specified element from a set. The difference between remove and discard is that discard does not raise an error in case an item is not present. Let me show you what that means. If we have a set like this and we want to remove a city that doesn't exist, so I'll say city dot remove, and then I say remove Mbarara. When I run this, it returns an error. It returns this error is saying probably Mbarara doesn't exist. It's called a key error. However, if I use discard, it doesn't return any error. In case the city doesn't exist in the set of cities, it just ignores. Okay, it's just like that. So sometimes it's really handy, and you will appreciate this as you are working on really big Python projects. Now, it turns out that you can also use pop to remove items from a set. The problem with using pop is that pop will remove items randomly from the set. So it's not it's not a thing that you may want to use every now and then. But in case you wanted, for example, to remove a random item from the set, you can use pop. Okay, an example is on the website here. When I used pop on the pets, rabbit was removed. In this case, rabbit is actually the last item, but because the set is not ordered, pop will just remove anything. Now, for your homework, I would like you to search how to find the number of elements in a set, and also how to check if an element exists in a set, and then try to use update to combine two or more sets. Okay, now with that, I want us to look at dictionaries. Okay, now a dictionary is an unordered and mutable collection of items. Dictionary also is written with curly brackets. Okay, however, the difference between a dictionary and a set is that elements in a dictionary are stored as key and value pairs. Again, I have a video here dedicated to dictionaries only, so you can check it out. Actually, it's really nice. However, I just want us to go down here and just create up some Python dictionaries. So let me just create maybe a profile. And again, we said we use curly brackets like this. And just to be organized, I'm just gonna move this other bracket down to the next line. And I will have a key, for example, city, and then I put a colon, and then I set a value like Kampala. Okay, and then I put a comma at the end here, and then I say country, and then I put a colon, and I say Uganda. Okay, okay, this is okay. This is a dictionary which contains information about some particular city. Okay, and I can print this one out just for completeness. This is how it displays when you print out its city, Kampala, country, Uganda, like that. Now, the way it works is that the first item has the key name here, and then the other one, its value. This first item here, it has a key, city, and then it has a value of Kampala. The second item also has a key of country and a value of Uganda. This is how items in dictionary are. They are set up in key and value pairs. Okay. The other thing we want to do is accessing items in a dictionary. The way we access items in a dictionary, we use the keys to pick these particular values. For example, if I wanted to pick out the first item here, I will use, I'll say profile, then I put square brackets, and then inside here I can pass in, for example, city. When I print this one out, it's gonna return Kampala. Okay, Kampala right here. We can do the same if we wanted to access the country. So we'll just say print profile, then colon, and then say country. Then this one should print Uganda. Okay, this is how we access items in a dictionary. Dictionary is really a common thing, and in future we'll be using it for creating tables where the key will be like the column name, and then the value, there will be actually many values to represent the elements under that column. So it's a really important thing. The way we add elements to a dictionary, we use square brackets and we pass in a key and value. So let me show you. If we want to add a new item to this profile dictionary, I can say profile, and then I open brackets, square brackets. Inside this square bracket, I can pass in the key, for example, continent. Then I can pass in the value as Africa. Okay, so let's put this one in quotes like that. Now, if I print the updated profile, we'll see that we have the city Kampala, country Uganda, and also we have the continent as Africa, just right there. Okay, we can also change items in a dictionary by accessing with the key. Okay, let's change. Let me just copy this. We can change if we wanted to. Let me just run this. If we wanted to change the city here, for example, we shall say profile. Maybe we saw some mistake and we want to change. We shall say profile. City is Nairobi for now, and if we print out profile, we can see that now Nairobi becomes the city. Okay, so to change the city value, you just say profile, square brackets, and then the key city, and then you set a new value for it like that. It's really straightforward. You may also be interested in removing items from a dictionary. We use pop to remove items from a dictionary. Pop has really become popular. And if we want to remove, for example, city from the dictionary, we can just say profile dot pop and say city. And then if I print out profile now, you'll see that we only have country, which is Uganda. Okay, it's simple like that. These things are really straightforward. Now for your homework, I would like you to see how to check if an element exists in a dictionary, also to find the number of elements in a dictionary. Also, I would like you to go to the website science.dataidea.org. Also, you can access it via Data Idea, and you just read about nested dictionaries. So sometimes you can have a dictionary inside a dictionary, and it's really a handy thing. You can just go read about it on the website. And there's also a free dictionary tip somewhere here, so you can just see another way to create dictionaries using the dictionary constructor. It's really nice. And then as an exercise, you want to write a program to store the marks of 5 students for you want to write a program to store marks of 5 students for 5 subjects given through keyboard. Calculate the average of each of the student marks and the average marks taken by all students. So not a really very simple exercise. So I'm gonna skip this one for now, and then we'll look at it later when we have honed our intuition upon certain concepts that I want us to look at. Okay, now you can take a break as we've come to the end of containers. Those are all we'll look at. There's another one called tuple, but you can just go to the website science.dataidea.org and you'll read about a tuple. However, for now, you can take a break, take some water, and warm up for the next part. In the next part, we'll be looking at Python flow control. All right, welcome back. Now, in this section, we shall look at Python flow control. Again, let's just create a new file. So I'll click on File and New Notebook in Drive. Then it will create us a new notebook in Google Drive. As I said, all the notebooks that you create in Google Colab are stored for you in your Google Drive. So, it means that all the resources that we are using in this video are also available on my Google Drive, and you can request for them, or I'll share a link in the descriptions. Okay, now here's the thing. Python flow control tools change the flow of how code is executed by the interpreter. This is because you see, sometimes you want to run code only in certain situations. You want to run a bunch of code only in a certain situations. We have different Python flow control tools. We have like functions, and functions allow us to run a block of code only when we want. We call that code to run. Then we have loops. Loops will run a certain block of code as many times as we wish. And then we have conditional statements that will run a block of code only if a given condition has been fulfilled. Now, all the materials are on the website. You can check them out. Also, there is this section. As I said, you can enter your email there to receive updates. Updates directly in your email. In this section, we'll begin with Python functions. I have a whole video dedicated to Python functions. You can check it out on the website. Also, it's available on YouTube. However, let's just look into some examples. In the previous section, we had some part where we were calculating someone's body mass index. Okay, we had their height, and the height was, I don't remember, maybe 175. And then we had their weight, and their weight was like 60 something kilograms, maybe 60 kilograms. And we learned that the body mass index can be calculated by getting the height over the square, or by getting the weight over the square height. Okay, the square height, also you can use the double asterisk like this, or you can just say height times height. It is equivalent to saying height squared. Okay, so we learned this, and we've also printed out the BMI as such. And here is the thing though, this code works really well. We can be able to get somebody's body mass index ready, but we have a problem. Oh, maybe this is supposed to be height and weight. Why is this body mass index really small? Is it height over weight or weight over height square? I think it's weight over height square. Let's just search formula for body mass index. It's weight over height. Okay, yeah, the height is in meters, so this one is in centimeters. So let's make this one 1.7. That's why it's so small. Okay, this one's body mass index is 19. Okay, this is okay. Okay, it's almost underweight though. but that's not the problem. Our problem is that in case we have so many people, maybe 5 people that we are targeting the body mass index for, shall we have to copy this code and paste it somewhere, 5 times? This is not sufficient. This is where functions come in handy. So functions will allow us to group our logic into one bunch of code like this, and then we can rerun that code whenever we like. So to begin with, we can bundle this logic into a function, and then we call the function whenever we want. So let's just do that. Now, to create a function in Python, we use the def keyword, and then we give a name to our function. For example, we can say calculate BMY like this. And so this one will check a function can have the logic as we said earlier on. For example, it can have the weight as 60 kilograms, and then height and as 1.75, and then we get the BMY as the weight over height squared. And then a function has one thing at the bottom here, it's return. So this return keyword will represent the output, will define the output of our function. So when we say return and then we pass a certain variable from up here, that variable is what this function will be outputting, sort of. So here, if we try running this code, by the way, when you run this code, we get some error because we're supposed to have a colon here. Sorry. So let me just recap creating. We have we set def, and then we give the name of our function. We put some square brackets, some rather round brackets, then we put a colon, and then we define the logic. Now notice that the logic is defined at a certain level of indentation. Again, we learned this one in the beginning, that indentation represents a group of Python logic or code. So this indentation level means that all these lines of code fall under this function. Okay, now if I run this, we get nothing because for a function to run or to be used, you have to like call it. Okay. And the way we call a function is we just write the function name like this. Okay, so if we get the BMY here, what is returned is this value. Now this is okay, but how this doesn't technically solve the problem that we had, that if we have so many people. Now to be able to solve that problem, we can allow passing in dynamic values for weight and height to this function. The way we shall do it is that we shall modify this function slightly. So let me just remove this, and then we shall have in between these brackets here, we shall have weight, and then we can put a comma, and then we can have height like this. So what happens is that when we are calling this function, we can pass in some values. For example, we can pass in like 60 for weight and 1.75 for height, and this one will return the same answer, okay, which is okay. So to be more precise and nice, I'll just set a new variable, and then I'll store the outcome from this function. I'll store the return from this function in that variable. So I'll say BMY is equals to calculate BMY, and then I will print BMY like this. This is better. Okay, whenever you want to calculate a body mass index, we can just call that function now. So if we have other values, so I'll just add a comment, say for 5 more people, and then we shall have BMYs, like that. for these 5 more people. So assuming that they have all this height, we can also modify this. Can somebody be less than a meter? I think so. Anyways, so we can have the difference body mass indexes. This one is overweight. This one is overweight too. But yeah, you get the point. We can now calculate for very many people as such like that. It's really easy and straightforward. So functions are really, really handy. We have more examples on the website. I think we have here a function for greeting someone. It's really simple. I can just copy that. So this function greets people, and the way we use it is we just call it. And whenever you want to greet someone, sorry, it's greeter. Whenever you want to greet, you just call this function, and then it will say hello. It's really simple like that. And I've talked about all this. There is really so many examples on the website. There is this example where we create a function that adds 2 numbers. Okay, let me just copy this one also, and we have a look at it here. Okay, this one adds 2 numbers, and if we call it here with 3 and 27, you see it returns 30. It's really nice. There is more. There is this one greets you by name, and it turns out that you can also set default values for these. Now, let me just clarify something, just for the sake of terminologies. If we have a given function now like this one to calculate BMI, when we are defining a function, at this part, it's called defining a function. And when we are defining a function, sometimes we pass in these variables which are representatives of the actual values that we'll be using. These ones are called parameters. Okay, if you just want to know the technical jargon, maybe for your interviews. And when we call the function here, these values that we pass in to replace these variables, they are called arguments. Okay, so parameters, arguments. It's a really common thing. So if you just know it, it's really good, maybe for your interviews. Now, the other thing I would like to mention is that the return statement will stop the execution of the code. So code that appears after the return statement will not be executed. I have an example to explain that on the website. Just check it out. And the last thing I want to show you under functions is the lambda function. Whenever you have some logic like this one, let me just copy this. Whenever you have some logic like this one, it's a function that is really, really small. It performs only one task to calculate the BMI. Okay, you can sort of make it narrow so that it occupies a really small space by using lambda functions. So a lambda function is also called an anonymous function, and the way it will work is we shall rebuild this code to look a bit like this. We shall say calculate BMI, and this will be equal to a lambda function. So we shall say lambda, and then we can pass in the weight and height, and then return. Let me just make it full screen. We can get the weight and height, and then we put some colon here, and then we put our expression, single expression, just right there. When we call this one, we shall see that it also returns. It also works same way as the old one, just that this one is all written on one line. Okay. um it's not a thing that you want to use all the time, but it has situations where it's really really handy, and we shall have more practice examples as the course goes on when we go into the next part of data analysis with Python. So hold on, if something skipped your mind, we shall understand it further. Okay, now let's go to the next part. There's even an example here where we calculate the CGPA, so you can check it out on the website. There is really so many examples. There's this example where we get the age and we print out. However, what I want us to look at next is Python loops. Now, this is a video about Python loops. I have a video dedicated to Python loops also. You can check it out. However, to just get started, loops are used to repetitively run a group of statements. Okay, so we have two major types of loops in Python. We have the for loop and the while loop. The for loop is used to loop through or iterate over a sequence of objects, over a sequence or over an iterable object. The way it looks like is like this. Okay, you just say for, and then you create a variable, and then you say in, then you pass in the sequence, and then you write a bunch of statements. Here we have an example where we are printing out the dogs. An iterable object usually is an object that contains other objects. Okay, a list is one of them. Okay, you can iterate over a list, and in this case we are looping over this list of pets. In the previous example we had our countries, so we can iterate over those. Let me just copy that and do the same. So we can say for city in cities. Okay, then we put a colon, and then we can go down here and say print city. Okay, it's really nice like that. So this one will print all the cities. We saw this similar thing under the set example here. Okay, so the for loop will run this statement print city for all the cities that are in this iterable object or in this container called a list. Okay, here is another example. In this example we run several statements as we are converting um, some weights to pounds. So let me just run through that example here. We create uh, uh, some weights as a list here. Okay, I'm just copying that, and what we want to do is we want to convert each of these weights that are in kgs to their pounds version. So when I was setting up this example on the website, I decided to create an empty list where we'll be storing each of the converted weight. So I called it weights in pounds. Okay, and this one was empty like this. Now we use the for loop and say for weight in weights kg. I said that the pounds version is the pounds version of that weight is weight times 2.2. It turns out that uh, one kilogram is like 2.2 pounds. I think last time I remember. So what happens is that I get the weights in pounds dot append, and now we learned append when we're looking at containers. We said append allows us to add an item to our list. So to this empty list we are adding the weight but now multiplied by 2.2. Okay, So the result is the weights in pounds as they are. Now, one thing we notice is that these numbers are, some numbers are a bit too large. Okay, there are so many decimal places, and I thought it nice to round off to decimal places. So, it looks nicer. So I said rounded pounds is equals to the pounds, and we round off to two decimal places. And now when we run, we will be having, let me just add here, rounded pounds. We'll be having rounded off to two decimal places. Now here's one thing. I said round off to two decimal places, but here we are saying that we have one decimal place in each of the situations. The reason is because there is zeros after that, and Python naturally will just remove other zeros. If the remaining other parts are including only zeros, it will remove them to keep only one decimal place, and that is why we only have one decimal place here. So just so you know. There is more examples of while loops on the website, rather of for loops on the website. However, for now, I want us to look at the while loop. Now, the while loop will execute a given group of statements for as long as a given condition is true. In this example here, we have a counter set to 0, and we check while the counter is less than 5, we print hello world, and then we increase the counter by 1. And then what will happen is that this print hello you will be run for as long as counter has not yet clicked 5. So what will happen is we shall have while counter is less than 5, we are beginning from 0, so 0 is less than 5. It will print hello you, and it will increment counter by 1. So counter becomes 1. 1 is less than 5, it will print you. Then counter becomes 2. 2 is less than 5, it prints this. Then it will become 3. 3 is less than 5, prints hello you. Becomes 4. 4 is less than 5, prints hello you. Now it will become 5. 5 will be um, equal to 5 and not less, so it will not print out any further. That results into printing out 5 times. Okay, it's really as simple as such. I'll just copy this and just to confirm that it works exactly as it does there. We repeat the weight conversion example, but now using a while loop, and I'm not gonna go through that one for now. So you can go to the website and you just check out, or you can also watch the video that I have linked there that contains more information on that. The last thing that I want us to look at in this section is conditional statements. Now, conditional statements in Python are really, really, really fundamental building blocks for controlling how your code will work. Because it allows us to execute a group of code only if a given condition has been satisfied. Okay, so we have the if statement as the control statement, the conditional statement, and the way it works is we shall just say if, and then we write our condition, and then we put a colon, and then below that, at a given level of indentation, we write some examples, rather some statements. Here in this example, we have x equal to 10, and then we are checking if x is greater than 5, print this. As you can guess, it's gonna print, let me just do that. So we have x as 10, and then you say if x is greater than 5, print x is greater than 5. If I run this, it prints x is greater than 5. Okay. Now what about this works very, very well if we only have one condition we are checking and we don't care for any other situation. Because, for example, if x was like 4, this will not print anything. Okay, and it may just leave you hanging, so you may just want to handle another part. So if we have one condition and we're also interested in any other thing, we can add on else. Okay, so let me just copy this example and I put it here. So shall say else. Now notice that else, if and else are on the same level of indentation, then I put a colon and then I print here x is not greater than 5. Okay, so if I run this, we shall see what will be printed is x is not greater than 5 because x here has become 4. We check if 4 is greater than 5, which is not, so this part will be skipped and only this part will be printed. Okay, what about if there is something we are interested in, and if there is one of those other situations, if we're interested in another one, because here we have a situation. If x is not greater than 5, then what is it? Is it equal to 5 or is it less than 5? So we need to handle that situation. So I'll just have the example copied down here and I'll extend this to check for another situation. Okay, we shall use a leaf like this. Now a leaf is at the same level of indentation with if, and here is the thing. We want to say a leaf x is less than 5. A leaf x is less than 5, and then we shall print, x is less than 5. Now we can say otherwise x would be equal to 5, because if x is not greater than 5 and then it is not less than 5, then the other one becomes is equal to 5. So let's just run this, and then we have this result as x is less than 5 because 4 is less than 5. Okay, if we set x to be also 5, we'll see that x is equals to 5. Okay, so these statements here, these print statements, are only run if the given condition for that section is true. Okay, it turns out that you can have conditions inside other conditions. This is called nesting conditions or nested conditional statements, and you can read about that in the learning materials, or you can watch that particular video dedicated to if statements and conditional statements. And also we have what is called the ternary operator, where we can have the if statement put on one line. Okay, we're not also gonna go through that. You can just check it out from the website. Okay, and there are also situations where you may want to combine expressions. We use the and or to combine expressions. So also more of that is on the website. Okay, and some of the practical situations where we apply conditional control statements when we are validating user input. Sometimes um, you are entering a password. You're trying to log in somewhere and then you're entering a password. If the password doesn't match the password that you set up when you're creating the account, then an error will be displayed for you, maybe like wrong password or something like that. Okay, so understanding how to use conditional statements is really crucial for writing efficient code. I have an exercise here where I ask you to write a program which accepts a number um, that is amount of money entered from the keyboard. If the amount is greater than or equal to 1,000 rupees, then a 5% discount is given to the customer. Then we display the final output. Now you can pause the screen and try this example and see if you can get it. If you are still watching, I'm just gonna go down here and develop a solution for that example. So they're saying write a program that accepts an amount input from the keyboard. So let's just get the amount of money. to be paid. So I will set a variable, say amount, and I say to input, to get a value by inputting, we use the input method. So just say input, okay, say enter amount. Now we can convert the amount to an integer by using the int method I showed you earlier when we are looking at data types. And then what we just want to do is want to check if the amount is greater than 1000 rupees. Okay, if the amount is greater than 1000 rupees, then we want to apply a 5% discount. The way this is gonna do is we can get adjusted amount to be equal to amount times 90 times 0.95. Oops, sorry, 0.95. Okay, and this one, well, if we can just print out the adjusted amount like as of now. So let's just print adjusted amount. Adjusted amount. Oh, there is a typo here. Adjusted amount. Okay, now let's run this. If we run this, there is an input field set up for us here. Let's enter some value like 7,000. Okay, 7,000 is greater than 1,000, so we get uh, 0.05 discount to result into this value, which is 6,650. Okay, if it is less, then we shall not have ourselves discounted. Okay, this is a simple example. There's so many examples that we'll be looking at as we progress, so stay tuned and watch all the parts of this programming for data science course to hone your intuition on these concepts. Okay, that will bring us to the end of this section. In the next section, we shall be looking at some slightly advanced concepts. We'll be looking at Python classes and objects. Okay, so yeah. All right, welcome back. In this section, we are going to be looking at Python classes. I have already created a new notebook, okay, the one we'll be using for this section. And so we shall just get started. So here's the thing. In Python, everything is an object. Okay, and talking about an object is just anything with like an attribute or characteristic and also a behavior. Um, everything is an object, and classes in Python help us to create new objects. We already have objects like numbers, lists, strings, integers, but you see, these objects don't necessarily solve all problems that you come across as a data scientist. Okay, so there is a need for you sometimes to create a completely new object that is not inbuilt for you in Python. In the example that we shall be using, we shall create a person object as illustrated here. So to create an object, to create a class which we shall use to create an object, we just say class, and then we specify the name of the class. This will later become the data type, the type of objects that are created using this class. And then we just put a colon, and then down here we can mention some attributes or behaviors of the class. For now, I will just set up first name, like here it is first name, last name, and age, like in this example. So I'll just copy this. Okay. Okay, now this is okay. Now we can create an object from this class that we just created. The way we create objects from a class, we just specify a variable to store that object, for example, person1, and then we can um, uh, call this person class like this. Now, this thing is actually called instantiating a class. When you create an object from the class, it's called instantiating a class. Okay, so if I just run this, we shall have a new object called person, and it's stored, a new person object rather, that is stored in person1. And if we just check the data type, so I can take the data type by saying type of person1, we'll say it's main dot person. Now person here is the thing that I want us to take away, so let me just print it as a whole. So it says class main person. Now I'm going to talk about this main part later, but for now I just want you to look at this person thing. This person thing identifies the data type of the new object that we just created. This object is of type person. Now this object has some attributes that we mentioned earlier on: first name, last name, and age. And the way we can access those attributes is by using the dot operator. So we just say, for example, person1 dot, and then we can say maybe first name. Okay, when we print out the value here, we shall see that the first name is Betty in this case. Okay, we can do this for second name. Okay, so I'll just do this, person1 dot second name. Okay, and if I just run this, we shall see that, oh, it's a first name, last name, sorry, it's first name and last name, not second name. So when I just run this, we see Kawala, and I can do the same for like age. Okay, so let's just do that for age also. Not age name, just age. 30. Okay, it's really really simple like that. Now here is the thing: when we create a new object and we just call them, for example, person2 is equals to this, we instantiate the person class. We shall confirm that the we shall confirm that the the first name, last name, and age of person2 is still Betty Kawala and also 30, age, first name, last name, and age respectively. But you see, many times you want to create objects of different characteristics. Two people may not be having exactly the same attributes like first name, last name, and age. So to be able to create two objects with different attributes, properties like names and the age, we shall modify our class constructor, our class rather, a bit. So let me just copy this. So currently we have this, okay. We just want to modify this a bit by adding in what we call an, an init method. So an init method is actually a function, okay, that specifies that sort of will set the attributes of this class at the point of instantiating. So we shall just say init, and this class is actually special, so you must always, rather this function is special, so you must always um, call its name like this. It's init. So we said def init, and then inside here, inside these brackets, we can pass in some few parameters. One is self, and then the other one is like first name, last name, and finally we shall add age. Okay, I can't see what is on that side, so let me just increase. Okay, now the next thing we want to do is we want to set self dot first name is equals to first name, and also self dot last name is equals to last name, and self dot age is equals to age. Now what are we doing here? Self, this thing self that we have specified here is used to refer to the object itself. It's like saying my, you know. So self refers to the object itself, and it is used in methods like this to refer to that object. So what we are doing here with the init method or the init function, we are saying set the name of this object, first name of this object, to be the first name that somebody passes in. So self dot first name, let it be first name. Self dot last name, let it be the last name that someone passes in, and self dot age, let it be the age that somebody passes in. Now, if we create an object with this class, we can be able to rather to create an object with some different names, last name, first name, and the age. Okay, and the way we can do this is by saying, for example, person one can be maybe Betty Kawala, like that. Okay, let me just do this in another cell to be more organized. Okay, like that. But we can also be able to create another person, maybe person two, that is James Bond. Okay, and we shall confirm that now when we check the first names and last names, they are different people. Okay, this is really, really nice. Now, in the next part, I want us to look at I want us to, okay, there are more examples here, by the way. There are more examples on the website. I'm just scrolling through because here there are so many examples. You can go to the website and search and read through those examples that I organized there to help on your intuition. What I want us to look at is methods. Now, a method, methods are actually functions in classes that can access class attributes. Methods basically just define how objects created from this class will behave. Okay. Um, for example, let me pick an example from here. Okay. Let me just continue with this example, with this person example. So I'm just gonna copy this person class. I can create a new behavior for this. For example, if I wanted to modify the names of this person and the age, and if I wanted to modify the names and the age, I can create a new function. I say update update maybe first name. Okay, and what is going to happen is that this function will take in self, and it will take in also the new first name that somebody has chosen. Okay, and what it will do is that it will set for this object the first name to be the new name that somebody has um has passed to the function. We can also add update last name and also update age as showed here. Okay, so in this way we can, when we create an object, for example, this James Bond, maybe let me just say person 3. If we create an object, for example, person 3 James Bond, like that, we can see their first name and last name and their age. However, we can also modify. For example, we can do person 3 dot update first name. Okay, update first name, and we can pass in the new first name that we want to to take up, want the object to take up. For so I can say, for example, JSON. Okay, and if I print out the new first name for now, see, we shall see that it's now JSON instead of James. Now there's one other thing that I want to show you before I go to the next part, is if you print out person 3, what do you think? I think the first thing you think is, when I print out person 3, I will get the first name, last name, and age. But it turns out that if you run, you get some funny thing like this, which is basically specifying that the data type, this is the type of the object, and it's stored somewhere at this index in memory, and it's not exactly something that you would have expected. So it turns out that to be able to print out meaningful information, you will want to add a special method called str, the string method. And in this case, I'll do def underscore underscore str underscore underscore. It also takes in self. And for now, I will you can just say return. Okay, maybe let me just create a profile. Maybe let me just say info is equals to um, um, first name. Maybe just say, let me, instead of info, let me just say full name, isn't it? That's better. Full name is equals to first name plus last name, like that. Okay. Yeah, full name plus last name. Why are we getting an error? Oh, it's self dot first name and then self dot last name, like that. Now, if we ever called this this object, we'll see now that we get James Bond, which is nicer. So this is a thing, this is a trick that I just wanted to show you. You don't have to always include it, but if you wanted to have some nice output like James Bond, when you print out the object, you may have to add it. Now, the last thing that I want to talk about under classes is inheritance. Um, Inheritance is a feature of classes that allows us to create a class that inherits or takes on attributes or properties and behaviors or methods of another class. Okay, say we wanted to create a student object. It turns out that a student is going to be having first name and last name. So instead of creating a class, say student, and you define the init method, okay, and then define the init method, okay, and then you pass in first name, last name, age, and then, for example, student ID. This is okay, by the way, this will work, but you don't want to do this if you already have a person class that has first name, last name, and age. So what you want to do is you just want to rebuild the student class to you just want to rebuild the student class to inherit the properties, that is first name and last name and age of the person class. So I'll say class student, and then you open brackets, and in these brackets now, but now we have brackets. So in these brackets, you can insert the class from which you want to inherit, okay? Then you can put colon, and now you define the init method like this. Let me just make this larger. You define the init method like this, which now takes in first name, last name, age, and student ID. However, now under the init method, you add on this you call this super class dot init, okay, and then you pass in first name, last name, and age. These are the items that we want to inherit from the parent class. So this is how it will be, okay. And then the only thing now we want to add on is the new property that doesn't exist in the person class, which is the student ID. Okay, it's really simple like this. This is what you'll do. Now, if we now we can be able to create a student with first name, last name, age, and also the student ID. For example, I'll do student one is equals to Betty Kawala, age 30, and ID 1. If I print out that, we'll see all these. The first name, the last name, the age, and the student ID is 1. It's really, really nice, this idea. And right now, things may be a bit strange, but as you practice further, you will hone your intuition. And also, as we go along with this Python programming for data science course, we shall learn where to apply some of these concepts that we are learning. Okay, I have more examples on this on the website science.dataidea.org. Okay, and you can just check out there. I have this simple example about an animal class, and we have a dog inheriting the attributes of an animal. Okay, really, really nice. And the thing that I want to mention is that the class that is inheriting properties from another class is called the child class, and it follows that the class that is passing on their attributes to the child is becomes rather automatically a parent class. So in this example, the person class is the parent, and then the student class is the child class. Really nice. Now this brings us to the end of this part of the Python course. In the next chapter, I want us to look at something really, really important, and it's gonna be Python modules, and that will probably wrap up this introduction. Okay, maybe we'll see if we can get time to look at file handling, but I wanted to look at modules most importantly. Okay, now we can stop here, take a break, and warm up for the next part of this course. Hello and welcome back. In this other part of the tutorial, we shall look at Python modules. Now, a module is a Python file that can contain variables, functions, and classes. So why use modules? Modules allow us to split our code into multiple files instead of writing all our code in a single file. So we can use modules instead of that. Now, at first, this looks like too much, but as your projects become really large, then you really appreciate the importance of Python modules. Now let's create a new notebook again as usual. So I'm gonna create a new notebook. And yeah, so as we said, a module is just a normal Python file. So here they're saying there's nothing special with creating a module. So you just simply create a you just write Python code and save with .py extension. And we have an example here that they have showed us that we have a module saved as my module.py, and this module has some information. It has a variable like first name, and it's storing that. It has last name, and it has all these other things. It has a function to multiply. I'll just copy this, and then I'll create a new Python file, and I store that inside there. Now, on your Google Colab, I use Visual Studio Code a lot, so I'm so used to it. But here you're using Colab. So in your Colab, you can click on this folder icon. It sort of presents for us an area for browsing files. So you just want to right click and then you select new file. So here we shall create a new file and we can call it my module, and then we can add an extension .py. Okay, that is what they told us that a module is. Okay, so let's just do that. And okay, it's been created right here, so we can open it now. See, it has opened on the other side, but everything is squeezed up, so we cannot see well. What I'm gonna do is that I'm gonna make this one take over the whole screen so that you can see what is on this side. Okay, maybe let me just also increase instead of taking over the whole with it. So let me just increase that. So I can close this window. I've already created my file here, my module.py, and it's just right here. This is just a Python file, so I'll copy this code and I'll paste it right here. In this code, we have first name Viola, we have last name Akulu, and then we have some functions. This one and this one adds two numbers, this one multiplies two numbers. I'll just add age, you know, for completeness, maybe 33. Okay, and then I'll save. Okay, now here is the thing. The way we use module now, like this one that we have just created, is we can go into our file where we are working. So this is a notebook. Right here we have our notebook and we have a cell. In this cell I can import my module. I can get stuff from my module by importing it. So what I'll do is that I'll just write here import my module, like that. So I can just run that. So once I run that, my module has been imported and we can find some stuff from it. For example, I can find the first name, maybe let me call it fn, by saying my module dot first name. Okay, and if I print that, print fn, okay, we see that it's Viola. Okay, we can also get maybe last name ln. Okay, and if I also print that one, so let me just print all of them like together. We can see Viola Akulu. We can also get the age, okay, as module.age, my module.age, and I can also print that one out. Okay, like that. So here we can basically just be able to use stuff from another piece, another code elsewhere in our main code that we are working from. Okay, we can even use these other functions. For example, we can use the function to add two numbers by saying maybe summation is equals to my module dot add 1 and 2, and if I print out the summation, we have 3 here, because my module has a function called add that takes in one number and another number, takes in two numbers and then adds them up, so it returns the summation as 3. This is really a nice thing to work around. So you know, let's just continue. It turns out that we can also use aliases. So an alias is like one name to represent the other name, the original thing. Let's take an example of my module. I can import my module as mm. Okay, is the alias of my module, and I can do everything that I did before but just using So for example, I can say, instead of saying here my module, I will just say dot first name and dot last name, like that, and then I can just get them again. Okay, it just works perfect. So to add an alias, we just say as. So for example, here we import my module as So it's simple like that. You can also import specific parts of a module. For example, we can import only this function that multiplies two numbers and we reuse it. So for that case, we shall say from. So I can say, for example, from my module import maybe multiply. Okay. Now in this case, I'll be able to multiply. So when you multiply two numbers, you get a product. So I can say the product is multiply, and then I pass in 2 and 3, and if I print out product, see with that we get 6. So you can even use only, you can even import and use only a specific part of a module. In this case, I'm using the multiply function. Okay, so to do that, you just say from my module import multiply. You can see all the items in a module by using this dar method. The way it works is you just say dar like this, dar, and then for example here my module. So let's just import my module, for example, as and then we can say dar and here we'll see all the things. These are all the items in dar. There is add, there is age, there is first name, last name, multiply, and a few other things that are automatically created for us by by Python. Okay, this is really nice. Now it turns out that there are some built-in modules in Python that we can use to perform some specific tasks. For example, there is sysconfig. You know, uh, in this example here we import sysconfig and we use sysconfig to get the Python version. It has a function called get Python version. Let me just copy this so that you can see. So sysconfig is already inbuilt in Python and it has a method, it has a function called get Python version. And we can use it to get the current Python version. The one that I'm using here is 3.10. Okay. There are also other modules like the math module. The math module contains some functions like sqrt, which just helps us get the square root of a number. Let me just copy this and have it here. So we can import, for example, math, and if we have our number like 16, we can get the square root by saying math dot square root. And if I run here, we can see the number is 16 and the square root of the number is 4. Also, there is one to get the factorial of a number. From math, also you can get the factorial of a number. Also from math, you can get some constants like e, like pi. Okay, here we have the examples illustrating that. And there are also other modules like random, which you can use to generate random numbers. Okay, there are other modules like date and time, which you can use to work with time. You can use that to get like the current time, time.now. So if I just paste this, you can see that the time that I am recording this video, it's 11:25. Okay, and this is the date 2025 January. It's 4th. Okay, it's this is when I'm recording this video. Yeah, so that's it. There is a lot of others like JSON. You can just come to the Data Idea website and then you can read about them. Okay. Okay, that's all. As an exercise, I want you to write a program to calculate the factorial of any given positive integer. So you can pause this video and try it out. Calculate the factorial of any given positive integer. So pause. All right. If you're still watching, I am just going to provide that solution. We can use the math module to do that. So we shall say import math. And then math has some function called factorial that we can use. In fact, we can just say from math import factorial, and then we can, if given a number maybe like 5, we can get the factorial of 5. So if we have a number like 5, we can get the factorial as factorial, and then we open brackets, and then we pass in the number value, and then if we print out, we shall get the number is 5. The factorial of the number is 120, and indeed the factorial of 5 is 120. Okay, that brings us to the end of this part of the Python course, and in the next section we shall look at working with files in Python.
Hello, in this section, we'll be looking at file handling. Python allows us to read, write, create, and delete files. And yeah, this process is called file handling. Now, I have a video about file handling. It's just on the website. You can go there, and also we have that little section for adding your email in case you want updates received directly in your email. Now, when reading and managing files, we use the open function, and the open function takes in two things: file, which is the path to the file that we want, and then the mode. And there are several modes. For example, there is R for reading, and then there is W for writing, and then there is A for appending or adding to a file, and then there is X for creating some exclusive files. Okay, so to begin with, we shall have a demo.txt file. Okay, and this demo.txt file is gonna be in our file viewer section, as you can see here. And we just want to have hello world and I love Python, 2 lines like that. Again, this is just a text file, and we shall perform some operations on it. We want to read, write, append, and delete maybe this file. So to do so, we shall create a new variable. We shall call it maybe open file, and we use the open function, which we saw. It takes in file, and it also takes in the mode. So we shall set the file as the demo.txt file that we have already, and then the mode we shall set R, which is like the mode for reading. Okay, now we can read the content inside the file by saying open file dot read, and we can store this content in a variable, just using content in this example. And then we can close this file. So we want to close that we don't have any issues with memory. But okay, before we do that, let's just print out the content. And then okay, here we have the content right here. Okay, okay, now let's go to the next thing. Before we go to the next thing, I think we first want to close the file. Okay, because leaving the file open in memory may cause us some problems in future. So for every other time we read and manipulate the file, let us also close it. Now let's go to the next section. In the next section we can see how to read files line by line, content in the file line by line. So we shall specify the file as demo.txt, and the mode we shall set R for reading again. Okay, and then we can read line. For example, line 1, we can say open file dot read line, And then also for line 2 we shall do the same thing. We shall say line 2 is equal to open file dot read line. Okay, this is okay. And then afterwards we shall print out the content, but before we print out, let us just close the file. Okay, then there we go. If we run this cell, we see the content. We have hello world, and also we have I love Python. Really simple. Now we'll go to the next part. On the next part, we want to write to a file. So there are two ways for writing to a file. There is W, which overwrites the content of the file. Also, it creates for us a file if it doesn't exist. And then there is A, which adds content to a file. We just want to begin with A. Okay, we want to append to our file. We already have demo.txt, and it contains some content. It has hello world, and it has also I love Python. Those are the two lines that are existing. So let's just begin with that. We'll do open file, the open file variable, and then we shall set it to this function, say open file, and then we pass in the file path. This is the path, the file, it's demo.txt. And then the mode, we want to use A for appending. And then we shall go to the next line, and we can add some code. Let's just do open file dot write. Okay, so we shall use open file dot write to write, say open file dot write, and then inside there we can pass in the content that we want to write. For example, I want to say I love JavaScript. Okay, there is already I love Python, so I will add I love JavaScript. Now here's the thing, I want to add this to a new line, so I'll use this backslash and n to add this text to line 3. Okay, so after doing that, I just want to close the file. Okay, and then I can just see what we have so far. Okay, so let's see, we have I love JavaScript also added. Okay, this is really really nice. Now the next thing that we want to do is we want to write to the file. So let's just see how to write. We shall say open file is equals to open, and then we shall again pass in the file, which is the path to the file, demo.txt, and also we shall pass in the mode. In this case we use W because we are opening for writing, and then we can say open file dot write, and we can say in this case maybe I love programming. Okay, and after writing again we want to close. We don't want to leave this file hanging in memory, so we just want to close. And then after closing, let's check out what we have. If we open demo.txt file, we'll see that we have I love programming. Now one thing you can probably notice also is that all the other content has been erased. Yes, that's how the write method works. It will erase every other thing in the file, and will only add the new text that you are passing in. In this case, we are passing in I love programming. Okay, it's a bit like that. So I think this wraps up. Maybe one other thing we can do is we may just want to check out how to delete a file. Okay, so let's say deleting a file. So to delete a file we use OS. The OS is a module. In the previous section we looked at Python modules and we learned how to use them. We learned that if we have a module, for example like OS, we can just import it. So we can do like import OS, and then we can use a function or a value of a variable that is in it. In this case, we have remove, which is used to delete a file, and we just do that. And if we run, checking on our file, oops, it's gone. Exactly. That's what delete does. It will completely remove our file. Nice. Now I have an exercise. This is a really, really long exercise. Okay. So I want you to go to their website, science.dataidea.org, to check out this exercise and see if you can do it. Basically, in this exercise, we are creating a phone book. Okay, we are creating a phone book where you can add contacts, add contact info, and you can be able to retrieve the contact info via a menu. Now, before we wrap up, just want to remind you how to get these materials. You can just search data idea, that is data idea without a space, and most likely the first result that comes, that one is the one that you want to go with. And on the website that loads, you just want to click on get started for data science. Okay, then that will take you straight to the science.dataidea.org website, where we have all the materials, including for Python. We have Python data analysis, and then we also have deep learning and machine learning with PyTorch. Okay, that is everything that you need for this other part. Now, in the next part, we shall be looking at uh, version control, I think, if I remember from the roadmap. If it's different, we shall confirm. Otherwise, maybe you can also suggest what you want me to look at next. Okay, with that, I would like to thank you and motivate you. Experience with anything comes from practicing. Okay, so you just want to practice every other day that you can. I advise you to use like 1 hour to practice every day, and then by the end of 4 weeks, maybe you are done with Python, and at large, at maximum, maybe 8 weeks, then you are done with Python. Just practice every day some of these concepts that are available on the website. All the learning materials are available on the website. So yeah, that's it. Now, thank you for your patience if you've arrived at the end, and see you in the next part of this lesson. Bye.